All right, let's do another example. Now we're going to use this set here. So we've got a set of two elements, and we're going to show that this set is linearly independent in the set of all quadratic polynomials. And so the way we're going to do that is we're going to set up our relationship, right? So we're going to show that we have what? C1 times 1 plus x plus C2 times 1 minus x equals what? 0 plus 0x plus 0x squared. So now what do we have to do? Well, we have to match up the x's and x's here, right? So to set up our linear system, let's expand this out and match it up as much as we can here. So if we expand it out, we get C1 plus C1x plus C2 minus C2x, which now we're going to get what? C1 plus C2 plus C1x minus C2x, and then of course we can continue on and we get, let's group these together since they're constant, C1 plus C2 plus, now we're going to get C1 minus C2 times x, right? This quantity times x is equal to 0 plus 0x plus 0x squared. Okay, now we can set up a system, right? Because what happens here? This just has a plus, oops. To match it up, that's all we have to do, right? Because there's a 0x here, so there's a missing term, the quadratic term, so the x squared term, so we're just going to put a 0x here, right? So this matches up with this coefficient matches up with this, and then of course this matches up with this, and so what do we get? We get C1 plus C2 equals 0. We get C1 minus C2 equals 0, right? And then 0, of course, we get 0 equals 0 for the bottom one. So we can just ignore that. Now what we're going to do is we're going to eliminate the C1 here, right? So we're going to take negative row 1, add to row 2, right? So if we do that, we get... let me erase this for a moment. I'll put it up here, plus. So we go here, we're going to get C1 plus C2 equals 0. And then what do we end up at the bottom? We're going to get 0. We're going to get negative 2C2 equals 0. And look at that. Well, we get C2 has to equal 0, and up here if C2 is 0, then C1 ends up being 0, and so we get C1 is equal to C2, which is equal to 0. And so we just showed that the set of x plus 1 and 1 minus x are linearly independent, or that set is linearly independent. All right, that's it.